It's a German newspaper. And welcome back to another video here from the Off-Grid Garage in sunny Australia. We're still having a winter, but you can see it's 23 amps outside. And the Multiplus is charging our battery from the tilt system. And I have received a parcel from Germany. One of my viewers, Raphael, he contacted me a while back and said, Andy, I've got this incredible multimeter here where you can change all the default settings to your likes and to your needs. And he made these two incredible videos and explaining how to do this step by step. And yeah, and I was really interested in how to do this, but I haven't got time for that because I'm here in the garage making videos for you. So, and after a few emails back and forward, he actually offered to send one of these modified, pimped, hacked multimeters over to sunny hot Australia. And it arrived yesterday. And it actually doesn't look much different to my existing one, right? So here I've got the UT210D and this is the UT210E. I don't want to go into any details here. So here's the comparison chart for all the three devices they have. So you can pause the video and read this yourself if you like. And Raphael was so kind to make all the changes for me in this device and send it over. So for example, if we turn it on and want to measure a voltage, it now starts in DC mode straight away, you know, while the old one starts in AC, and you have to click select. It goes to frequency, select, and then it goes to DC. This one does it right away. If we select resistance, it starts in continuity test. Here in the old one, it measures your resistance, and I have to click on select, and then it goes into continuity mode. With this device, we also have a 2, a 20, and a 100 amp, which all have been modified as well. So the 2 amp current selector gives us a very fine resolution here of 1 milliamp. So we can actually use this device here to measure these micro amps of balancing currents in these BMSs. And also the 100 amp selector here goes now to 1000 amps. So it can measure up to 999.9 amps. And I think he also modified the backlight, which is now on and doesn't turn off in 1.2 seconds anymore like the old one. This one stays on for now 10 minutes. He also set the timeout to 60 minutes, so the device doesn't turn off after 10 minutes as the standard one. Yeah, the light is still on. I think I can turn it off by holding the button again. Yeah, you can manually turn it off, or it lasts 10 minutes now, which is fantastic. So we're probably going to use this new multimeter directly in this video today because we need it. Because we want to measure the balance current of the new SEPLOS BMS version 3. And I guess this 1 milliamp resolution comes in handy now. I'll link Raphael's YouTube channel and the two videos he made how to modify, how to pimp, how to hack these devices here under my video. So please check it out. He made a step-by-step procedure and showed you in all details how to do it yourself. And it is all in English. So thank you very much, Raphael, for sending over this Unity UT210E and hack and modify it for me. That is very kind and very generous. Thank you very much. And also thanks for the branding. And guys, in today's video, we want to have a very close look to the new SEPLOS BMS version 3. Many people have waited for this new BMS for a long time, because it is supposed to have some great features we were all waiting for. And today I want to show you how the BMS works and what these new features are. So in the last video, when I introduced the SEPLOS Polo batteries, we already had a quick look at the version 3 of the SEPLOS BMS. So I didn't take the BMS out of the case here, because there's not much new from a hardware perspective. As already mentioned in the last video, the only obvious change is that we are now switching the negative of the battery, which I think is a big mistake. And I have asked SEPLOS several times now what the intention was to change this whole design of this BMS. And I didn't really get a clear answer. They said switching the positive could be problematic. It could also destroy the BMS. And the decision was made to go in line with all the other BMSs out in the market. So from my perspective, it doesn't make sense to switch the negative. You should always switch the positive. But hey, I guess this is the first new feature of this BMS. Another change of this BMS, which is invisible, is that the Bluetooth module is actually sitting on the PCB now and not in the display in the front anymore. So I guess these displays are not interchangeable either. Apart from that, we can see all the balance cables here on one side, which are connected with two connectors, like with the old BMSs. We've got two terminals on the PCB, and they have actually connected these with a small bus bar. So we don't see any flat bus bar cables here anymore, like in the other SEPLOS batteries. There are also three different variants of this BMS in their store. There's a Type A, B, and C. And if you have a quick look at their website now, we can see the Type A, Type B, and Type C here. And these different types only differentiate by either having all the functions on one PCB, like in the Type A. The Type B has the communication and the lights on a separate PCB connected with a cable. And the Type C has the communication board and also the lights for the battery gauge and a separate PCB, and you need to connect them via a cable. So here we can see the separate PCB for the communication on the back, and we have the LED gauge here at the front. So this is a BMS Type C. All the components are separate and then connected with a cable to the main PCB. And we can also see that some of the BMSs are actually offered with a 2 amp balancer board, an active balancer board. And further up in this list, we can find the SEPLOS 2 amp active balancing board for LFP lithium iron phosphate batteries. There are 3 different photos showing the PCB and like 16 relays or so. And we can also see 2 8-port connectors here on this side and a few more connectors here on the top, presumably to connect it back to the PCB. Here we can see the back side of the PCB. Doesn't tell us much. And this is actually a very interesting photo because you can see we have 16 or 17 balance cables here connected with ring lugs to connect to your terminals of your battery. And this looks very familiar, right? And if we scroll further down and read the text, which says, SEPLOS active balance board can be used separately or compatible with SEPLOS BMS 3.0. It utilizes the bidirectional energy transfer and transfer the energy from higher voltage cell to lower voltage cell. So nothing new. The emphasis on this reads on the word separately. So obviously this is a standalone active balancer board, which you can just connect to any battery, and it balances your battery with 2 amps. Further down here we have the parameters, which are actually looking very scary, because it doesn't seem like this balancer board has any functionality like Bluetooth or RS485, or even these parameters can be changed somehow. It looks like they are fixed values. That's how I read it. And balancing will start at 3 volts per cell. If all the cells go under 2.9 volts, the balancer will stop. If these settings cannot be changed, it is horrible. It needs a deviation of 50 millivolt to start, and at 30 millivolt it stops balancing again. It balances for 60 seconds and then stops for 3 seconds to measure the voltage, and then starts another cycle. I've got a 2 amp active balancing current and a 50 milliamp standby consumption. Reading all this here, and nowhere on the website it says we can change these parameters. So for me, it looks like these are fixed parameters in this active balancer, and it just does that, nothing else. It starts over 3 volts and it stops under 2.9. So this would mean this active balancer will balance all the time. And this is exactly what we don't want, because we have tested this many times here on the channel, and keeping an active balancer running for all the time with lithium iron phosphate will actually do the opposite. It imbalances your battery pack. And this is because of the flat charge and discharge curve of these batteries. Balancing lithium iron phosphate does not make sense below 3.45 volts. So obviously SEPLOS has invented the wheel again and tries to push a device on the market which is already obsolete and outdated. Of course, I have asked them if these parameters can be changed by the customer or if they can be changed while the balancer is connected to the BMS version 3. Well, I didn't get an answer. Nothing. Zero. And there's nothing mentioned about a Bluetooth connection or an app or any other settings which can be changed. And again, reading the word separately, it looks like this is a standalone device. You connect it and it starts working. And I'm telling them for over a year now, why are you trying to invent the wheel again? We have solutions out on the market. Why don't you just take these components and use them? We have already perfectly working active balancers. Just turn them on with a setting in your parameters. Like Müller Energy did with the JBD BMS. Got this modified from the manufacturer, and now it turns on your active balancer the same time the passive balancer of the BMS turns on. And it works perfectly. But here we see yet another separate standalone product. New development. Guys, let me know, have you actually ordered one of these devices already and can tell us a bit more about it? Because I don't think I got contradicting information from SEPLOS. Once they tell you, yes, the BMS has an active balancer, well, my BMS doesn't have one. Then they are saying, well, there's no demand for active balancing, it's not necessary, so we don't go ahead with the development. And then they tell you it is still under R&D. And it's not as easy to develop an active balancer. I mean, why would you do it? It is already there. Why would you spend money on research and development if the product is already on the market? And many people have already these balancers, so just give them an option to connect this one to a SEPLOS BMS. This is all we are asking for. I guess this is Chinese mentality. So yeah guys, let me know in the comments down below if you have already ordered one of these active balancers from SEPLOS and got it delivered. Or are they still telling you it's not available yet and is still under development? Because if they would have these active balancers already, they would have sent me one. So I can test it and show it here on the channel. But they haven't. Yeah, guys, unfortunately, I guess none of these new SEPLOS BMS's version 3 are coming with an active balancer. This one certainly doesn't have one, and you can see these tiny balance currents here. So the expectation of the passive balancer built into this PCB here are very low. Okay, I guess so far this quick introduction of their products and technology. So, I have now connected the top battery here because it's fully charged already. We have connected our CAN communication cable from the battery to our Servo GX and also have connected the computer with a normal computer cable and using the SEPLOS RS485 adapter to USB. So, let's start the BMS Studio and click on Start. And we can already see that the state of charge is on 100% and we have not exceeded any pack over voltage protection or cell over voltage protection or any other protection parameters. It has just reset to 100% at not even 55 volts. And I want to open the BMS Comparison Spreadsheet again because here is already the SEPLOS version 3 BMS. And I put already a lot of details into this spreadsheet. And we want to jump the curve here a bit. Reset trigger to 100%. Usually with the older BMS, you can see we only have the over voltage protection, which then resets the BMS to 100% state of charge. And it turns off your charge MOSFETs, it goes into a protection state. And this is always what I disliked with the SEPLOS BMS. They always needed this protection status to just reset to 100%. And clearly, if one cell hits 3.65 volts, this doesn't mean the battery is on 100%. This is only one cell is on 100%, but not the other ones. And I've complained this since day one with SEPLOS, and maybe because of that they finally have changed it. And now we have 4 triggers which can actually reset the BMS to 100% state of charge. There is still the possibility to run into a total over voltage protection or into a cell over voltage protection, which either will then reset the BMS to 100% state of charge. There's also the possibility that our battery voltage, the overall pack voltage, is larger than our cell high voltage alarm times 16, because this is a 48 volt battery system. We have 16 cells in series. So it's the high voltage alarm times 16. And our battery voltage needs to be higher than this setting for 30 minutes. And this also resets our BMS to 100%. As we can see here, We are under 55.2 volts, which is our set voltage to charge the battery to, but we have a cell high voltage alarm triggered. So you set this alarm accordingly to when you want to trigger this 100% state of charge reset. And this is actually good and not so good. I'll show you this in a second. And the fourth option is our battery overall pack voltage, our battery voltage, needs to be higher than the cell high voltage alarm times 16, and the current needs to be under 0.5 amps. This is a trigger which does not work for me, and I think it won't work for anyone because if we go a little bit further up in this spreadsheet here, we can see the actual threshold the BMS starts measuring sits on 0.8 amps. So everything lower than 0.8 amps, the BMS doesn't care about. This is the resolution of the BMS. And if they state the charge current needs to be under 0.5 amps, well, it isn't, because it's 0. And I think this is why this option is not working. So we can only use the third option here, that the battery voltage is higher than 16 times our alarm, our cell high voltage alarm. And something else we can see already as well is that the charge MOSFETs are actually staying on when the reset to 100% occurs. And now you would think, hey, this is great, because now our charger can still supply power to our loads. No, it can't. Because let me show you something else. If we go in the Victron VRM, we can see the parameters of the BMS. This is what the BMS sends to your inverter or to your charger, to your MPPT. And what can we see? The charge current limit sits on 0 amps. So when the BMS goes to 100% state of charge, it sets the CCL to 0 amps. And this means, let's have a look at this SPED calibration center. You can see the battery sits on 100%, the charge current is 0, and the PV charger doesn't do anything. Let me turn on a load. Okay, I have now connected a 100 watt load, and we can see we are discharging with 150 watts, negative 2.7 amps, confirming this here in the app as well. So what we are doing right now is discharging the battery, right? It is taking away this power from the battery and not from our solar. See, the solar still sits on 0 because the BMS tells the charger, I'm full, shut up, go to 0 amps. And your solar is sitting out there and doing nothing while you are discharging your battery. Fortunately, it is not as bad as it looks like, because it will engage the solar charger again or your inverter if the state of charge changes down to 99.9%. Okay, let me increase the load here. So discharging now with 12 amps. And now our state of charge has dropped to 99.9%. And if we have a look at the Victron system, we can see the charge current limit is now increased to 80 amps from 0. So it allows the solar charger to kick in again and deliver power to the system, which is great. Okay, I have now turned off the load again, so I'm going to recharge the battery. And while we are charging, we want to have a quick look at the parameter management. So here we can see the number 12, the cell high voltage alarm. And this value here times 16 is your threshold you need to exceed with your battery voltage and then wait for 30 minutes to reset to 100%. So this is like 3.438 times 16. This would be exactly 55 volts. So the battery voltage needs to be over 55 volts for half an hour, and then it resets to 100%. Okay, let's give this a few minutes here until the first cell hits the high voltage alarm again. It may take a moment. Okay, so at 3.438, we have a cell high voltage alarm, right? With one of the cells. 3.438. So we are very close. Cell number 6 is hitting this threshold. And once this is happening, we will see the alarm coming up, the cell high voltage alarm, and have a look at the CCL then up here in the Victron system. There we go. Alarm comes, and look at the CCL. Yeah, so it goes down. Yep, so it sees the alarm coming up and says, well, something is not right here. We are a bit high with our voltage, either cell or pack. So it's better to reduce the power actually going into the battery, reduce the charge current, and it is telling everyone. It is telling your inverter, it is telling the MPPT, it is telling your system. only charge with 10 amps now. I mean, we're only charging with 3.7 anyway, so there will be no effect in this case. But if you would charge with like 40, 50 amps now, it will actually limit your charging current to 10 amps only. And it keeps the current limiter until this alarm goes away again, until you hit the recovery voltage. Okay, let's have a quick look here in the settings again. We can see number 102 is the charging request voltage, sits on 55.2. And you can see this here in the Victron system as well. Charge voltage limit 55.2 volts. Checking our monitor, we are at 55.05 volts and the current is already tapering off. Let's have a look at the solar charge controller. Solar charge controller is doing fine. It does exactly what is being told by the BMS. It charges to 55.2 volts. So here our battery will never reach the 55.2 volts. Never, never, ever. Because the measurement of the BMS and the charger, the MPPT, are different. And this is partly because of a voltage drop, because the MPPT is further away from the battery. But 0.6 amps are not creating much voltage drop anymore, right? And this was the reason I have set my reset voltage to 55 volts, not to 55.1 or 55.2 volts, because the BMS will never show that. So if you tell your charger to charge to 55.2, but your battery will never reach that, you are not triggering the 100% state of charge reset. So set this one a little bit lower, 55.1 or 55 even, and you'll be fine. As we can see, the battery has fully absorbed now. We are charging with 400 milliamps into this pack, and the voltage will come up a tiny bit. I have seen 55.09, but it takes hours to reach that because charging current is so small now, which is perfect because we are balancing, right? We don't want to have a high charge current while we are balancing. Balancing means we are taking energy away from the high voltage cells. So the battery is basically absorbed now. It is just waiting for the reset to 100%. Some of the cells are balancing, and we can see here the solar charge controller still delivers 100 to 200 milliamps into the battery, but mostly the battery is full now. It's saturated, it is absorbed. So if we now introduce a load, we turn on our load again. Okay, very small load, 50 watts only. And 3 of the 4 solar panels on the pool fence are already in full sun, so the solar charger should have no trouble to deliver these 50 watts, and you can see it doesn't have any problems with that. So nothing goes in the battery. PV charger delivers the energy to our load. So that's pretty perfect, right? Okay, let's increase the load. So for a moment it takes the energy out of the battery because it needs to wait for the solar charger to ramp up. And then the solar charger recharges the battery. And now we are at 0 again. So that's just a small peak the battery delivers until the solar charger ramps up. Let's increase the load a bit more. Again, we will see a spike, which is coming from the battery, and then the solar ramps up. So we now have a current of our DC load of 9.5 amps, right? And here comes the problem with that. The BMS still tells our solar charger, well, there is a limit of how fast you can charge into the system of 10 amps. And these 10 amps, this is not the current going into the battery. This is what the solar charger can deliver. If we go into the pool fence solar charger and go into network operation, the solar charger knows it needs to charge to 55.2 volts and the maximum charge current is 10 amps to reach that. So if I increase the load just a tiny bit now, we will see we are at 10.8 amps for our load. And we are taking energy out of the battery already. We are discharging the battery now. Even the solar would be enough to deliver all the power for our loads easily. It is being told you can charge only with 10 amps. But we have a 2 kilowatt system here on the pool fence. But we cannot deliver 600 watts to our load without involving the battery. Okay, I have now reduced our load to 200 watts again. And we can see the solar charger is now recharging the battery again because it wants to reach this 55.2 volts. And here we can see in the solar charger we have reached the 55.2 volts again, and basically the current is now tapering off, delivering still power into our load, but not in the battery anymore. Now you can see our load is 4 amps, and this is exactly what the solar charge controller delivers at the moment. Even it could deliver like probably 1000 watts or something. Okay, so while we are waiting for the battery to charge to 100% again, I can show you a little trick in the Victron system here when your charger shows a different voltage than your BMS. And as I said before, we know the BMS is actually correct because it measures very close to the battery. So this should be our point of truth. Everything else afterwards, there are cables, connections, terminals in between, which can somehow change the reading of the voltage with any device afterwards. So BMS, point of truth. Yeah, and the charger sits here on 55.18, so close to 55.2 volts. It does what it's supposed to do, but our battery sits on 55.06 only. So if we go into the Victron remote console, go into settings, and here we go down to DVCC. So you should turn on DVCC when you have a BMS connected, and then you turn on the SVS, the Shared Voltage Sense. And what this does, it basically tells all the devices in the Victron system to listen to the BMS. So we will see now, let me turn this one on. Go to the Victron page again. So this is our battery voltage, but the solar charge controller sits a bit higher. So what this setting does is it tells the solar charge controller, take the voltage of the battery. And the current is already increasing in the solar charge controller. And now it is actually adapting to the BMS and charges the battery to the actual 55.2 volts. So there we go. Battery voltage has now increased to 55.2 volts. Perfect. So now we are charging for half an hour, and the battery should reset, or the BMS should reset to 100% at any time. It's not doing it. It's very hard to know when the half an hour starts and it triggers actually the event. And if the voltage dips only for a microsecond under the threshold, it restarts the timer of the half an hour again. Which doesn't really matter in practice, you know, but here filming it and capturing this event when the BMS goes to 100%, it's almost impossible because I don't know when to start recording. So when we hit the 100% state of charge, it doesn't turn off our charge MOSFETs, but it will change the CCL, the charge current limit, from 10 amps to 0 amps. And this will basically completely turn off your solar charge controller then. And the load, which is still connected to your system, will then be powered by your battery until the battery goes down to 99.9% again. And then the whole cycle starts again, as we have seen at the beginning. I cannot really demonstrate it because it is very hard to know when it actually jumps to 100%. I don't know when this half an hour started counting. But you have seen at the beginning of the video, the charge count was at 0 because we were on 100% state of charge. So and during the day, it would actually cycle at 99.9%, 100, 99.9, 100, 99.9, 100. And always discharges this 0.1% of your battery and then recharges it, waits for half an hour, and then does it again. So it basically keeps the battery on these 55.2 volts until the sun goes down. So SEPLOS came up with a solution. Well, at least it is a SEPLOS solution. Let me find this setting here. Here it is, number 84, which is the power supply state of charge. In percentage, it sits on 96%. In previous software versions and BMSs, this was called the gap charge function. What this does, it charges your battery to 100%. And then turns off your charge MOSFETs, so there's no charge coming in anymore, until the battery reaches 96% state of charge. Then it turns on the charge MOSFETs again, the battery gets charged again to 100%, and the same happens again. And as you can see, this is just a setting, a parameter here. You can even set it down to 90% if you want to. Then the battery would cycle between 100% and 90% all the time. And there's also a function switch number 50, which is the intermittent charge. If this one is on, this function is turned on. The problem with this is, to trigger this function, you need to have an over voltage protection situation, either pack or cell. So one of your cells needs to hit the 3.65 volts, or your whole pack needs to go over 58.4 volts. And then it triggers this gap charging functionality. And you can already see how many compromises you actually need to go through with this BMS here to make it somehow work. It is not clear what is happening. There are so many functions and features in this BMS here. It is very hard to keep track of that and make the right decision and set the parameters correctly. And we can see over here all the cells which are red, they are over the cell high voltage alarm threshold. Deviation of the whole pack, 211 millivolt. Insane at 55 volts. And here, number 81, we can see the equalization open voltage is at 3.45, and the difference is set to 10 millivolt, and we stop at 5 millivolt again. So 3.45 volts is our trigger voltage. And now you can see, well, what about cell number 5? It is over 3.45. Cell number 7, cell number 8, cell number 11. They all are over 3.45 volts, but there's no balancing. I asked this question many, many times in our SEPLOS chat, and apparently this is per design. They are trying to avoid the balancer is getting too hot. So that's why they are not balancing ejecting cells. Cell number 6, we cannot balance cell number 5, and neither cell number 7. There is a risk of overheating and a risk of a short. Just passing on what I've been told. And if we go higher with our pack voltage, this is why I can always see only battery number 3, 6, 9, and 12 are balancing. None of the others. I've never seen any of the other battery cells balancing. Okay, well, the battery is still open. And we have our brand new hacked multimeter from Raphael. Thanks. Let's check it out. Well, so I figured this cable here, this one here, is our balance cable number 6. This is number 5, this is number 6. It's a bit hard to get on camera, but they have labels actually. So let's see if we can grab this one. We set this one to 2 amps, 0 fiddly. Okay, got it. Got it. So number 6. And we can see a balance current here of, yeah, that's milliamps. 10 milliamps. There you can see it. It's about 10 milliamps for cell number 6. And cell number 6 is what we are balancing. It's 10 milliamps. So when they told me, well, the balancer gets too hot if we balance too many of these cells, I was a bit excited because I thought, well, then it has to have like 400, 500, even 700 milliamps or something per channel. So a couple of watts per channel. But now we are measuring 10 milliamps. I mean, really? 0.01 times 3.5 volts. That is 35 milliwatts. So again, this is as disappointing as it can get. And I don't understand why you would develop a new BMS, a brand new BMS from scratch, with a passive balancer with 10 milliamps balancing current. Mind blown. So this is again what we have to deal with the SEPLOS BMS and the settings and the software. Not straightforward at all, very complicated, very irritating, and it took me a long time to figure this all out. I'll put all this information into the BMS spreadsheet, so you've got it easier. You just go into the spreadsheet, I'll link this down below. And under the version 3 of the SEPLOS BMS, you can find all the parameters and information how to set it up and what these different features do. Okay, so in the next step, we wanna parallel these 3 batteries now, at least from a data perspective. So before we go ahead with that, I just want to talk about these two connectors here, the RS4851 and the RS4852. Usually they are the same, right? They are in parallel, and it doesn't matter where you plug in your computer, if in one or two. Well, not so much with the SEPLOS battery or BMS. The computer needs to be plugged into port number 1. It will not work on port number 2. And I also claimed this with SEPLOS, and they told me I don't have the newest version of their RS485 USB adapter, obviously. This is the one they delivered with the Mason battery boxes, and it has worked so far, and it also works with this BMS, but only on RS485-1. Alright, so we want to have a quick look in the Smart BMS again in the Victron remote console, and we can see we've got one battery online at the moment, and it shows us the highest, lowest cell voltage and temperature as well. Further down it also tells us we've got 100 ampere hours of 100 ampere hours available. This is not the state of charge it shows, so it will not show 100 ampere hours is installed and available are 77% if your battery is at 77. No, this is only what is available right now if the battery is online. If it's online, these 100 ampere hours are theoretically available. If you have 5 batteries connected and one of them is offline because of an overvoltage protection, for example, it will show you 500 installed, but only 400 are available at the moment. So anyway, we want to keep going here. All right, so I have here a 0.5 meter of patch cable. This is just a normal computer patch cable. And we want to connect the BMSs together now. Because these BMSs have automatic setup, we don't need to set any dip switches here for any of these BMSs. They all can stay on 0. Yeah, right? Okay, so we connect this one end to the second port, and here the other end connects to port number 1. And we can immediately see in the Victron VRM we've got now 2 batteries online and both are available. Now we can see the lowest cell voltage is in pack number 2, while the highest is in pack number 1. So very easy, right? Very straightforward, no dip switches, no confusion, nothing. What happens if we take this and plug this into the second port? So from port number 2, this blue cable goes down into port number 2 of the next BMS. We can see it's not working. Right? So these ports are actually not in parallel in the SEPLOS BMS because of the automatic configuration they have set up. It needs to be 2 to 1, 2 to 1. And they explain this has something to do with the automatic addressing of these batteries. So because we are here in port number 2 with the blue cable, we need to plug this in here to port number 1 down here. And immediately we can see, can we? Yes, here it comes online. 2 batteries online, 200 ampere hours all in total. Okay, let's do the third one as well. Port number 2 of this battery goes to port number 1 in this battery. I think I need to start this one here. This one is on, second one. Yeah, this one, I've never turned this one on actually. Here, there's the reset. Just press it once. Yeah, light comes on. And we can already see we have 3 batteries online, all of them very happy together. So this is very straightforward, right? And it is so much better than having these dip switches and looking in these tables. And okay, let's go into our software. Oh, the software has now stopped. The software doesn't connect anymore now because we have now several batteries in parallel. So let's go into parallel view maybe. Well, there's nothing here. So what you need to do is bottom right of the BMS Studio. It is at the moment in standalone mode. Click on this one and go to parallel mode. This will then connect to all of our batteries. See, pack number 1, this is our top battery, middle battery, and the bottom one. Is it? 53 is the bottom one. Yes, it is. And it gives us all the information of all 3 batteries because And because they are not connected to each other, so none of the battery terminals are connected to each other, we of course have different voltages. Yeah, this one is fully charged, as we know, 55.4 something. And the other two batteries are roughly half charged. And it gives you also all the information: min, max cell, min, max temperature, remaining capacity, and the amps for this battery pack. You can now double click on one of these batteries. See, this looks very similar to the standalone mode we were in before. But you can also see all the tabs are missing up here. So you cannot go into the configuration of any of these batteries in parallel. You can read all of them individually, but you cannot change any parameters. If I want to go in and say, well, this is on 55.4 volts now, this is far too high, I want to change this back to 55.2. Well, there's no way. There's no way. I would need to go ahead and unplug the parallel connection from the top battery to the other two batteries, and then just plug in my computer into the top battery, which is then again a standalone battery. And I can do the same with the battery in the middle. Shows us 46.6%. Obviously there's no current going in because it's not connected, but I can see all the details of this battery as well. And here, third battery as well. Bang, all the information. So how does this look like in the Victron VRM now? Well, the solar charge controllers or your inverter still knows it needs to charge to 55.2 volts. And the charge current is 35 amps. This is the maximum this MPPT can do. It usually shows, if we go parameters, it should show us 160 amps now. 80 amps times 3. This is valid for the discharge current, so I can discharge 80 amps of each battery, but charging is only 160. Something has happened. Battery number 1 has reached a cell over voltage protection. One of the cells went over 3.65 volts and charge MOSFETs are turned off for battery number 1. And if we have a look in the details of the smart BMS in the Victron console, we should actually see one battery offline. No, it's not. You would expect one of the batteries is now offline because the charge MOSFETs have turned off. But this is not the case, because we still can discharge the battery. It's fully charged, doesn't take any more, but it's still online and we can discharge it. There's still power in it. See, I still got 300 out of 300 available to discharge. The capacity is still there. Well, SEPLOS has now fixed the problem that we can actually see the data of our master battery. We can still not change the parameters of single battery packs. Even all the RS485 communication is now established and working. I cannot change any parameters of any of these three packs now. I need to be physically on site and basically disconnect this battery from all the other batteries, have my computer plugged in and my CAN to my charger, and now I can actually change the parameters of this pack again. If I want to change these parameters here, I need to unplug both of the communication cables and plug in my computer to port number 1. We are still so limited what we can do with this communication between these batteries. So what is going on now? Now our battery with the 100% state of charge is pack number 3 all of a sudden. Well, what I have done now is I have changed the order how I plugged it in. So the computer is now plugged into the bottom BMS, and I have swapped all these connections over. So port number 2 from here goes to port number 1, port number 2 goes to port number 1. Depending on where you plug in your computer, this shows always as pack number 1. Okay, this bottom battery doesn't show any data here in the Victron VRM because I have never connected to this battery and I have not set the Victron protocol as the communication. This shouldn't be a problem because we can also change the parameter on the display now. Yes, that works. Protocol. Confirm. It sits on Sun 3 something, whatever. We need to find the Victron protocol. GoodWe SMA Victron CAN protocol. And then you need to confirm twice. And we also have to plug in our servo into the bottom battery now because this is our master battery. You cannot plug in your communication port to your inverter into any other battery than the master. And I'm still having difficulties to understand what makes the master. Because usually you don't have your computer plugged in anymore. So I've got one battery at the top, in the middle and bottom. And the BMS communicates to our Victron system through the bottom battery. If I plug it into the top, it starts beeping. So how does it know that this one is the master? So the only difference we have here, there is nothing plugged into port number 1. While here at the top, port number 1 is our communication port. So the master battery is being determined by having nothing plugged into the first RS485 port. Pretty much like here. Master, not a master. Definitely not a master. So then let's have a quick look in the smart BMS again here in the Victron remote console. Yeah, 3 online and 300 out of 300 ampere hours available. So let's have a look in the parameter section though. We now have 57.6 volts as the charge current limit, not 55.2 as we have set in the battery before. But the battery we have set this in is not our master battery anymore. This is the one charged to 100% and it was sitting on 55.2. But now the bottom battery is our master battery. And I've never changed any parameters and I've never connected to this battery before. So this is all default settings now. And it charges to 57.6 volts. It tells the charger, charge to 57.6 volts. But we also know, connecting to the 100% battery here, this one cannot be charged anymore because we had a cell over voltage protection, right? And it needs to wait for the recovery voltage, which is at 3.6 or something, or 3.55 or somewhere. So if we push charge into these 3 batteries now, only battery number 1 and 2 will charge. Number 3 doesn't, because this one is protected. This one has a protection status. And you can't really see what is happening here because this is a very frequently asked question. If you have these batteries in parallel and the parameters and the settings are different, well, it doesn't really matter. Each BMS is only looking after a single battery. Pretty much the same as in my battery shelf with 3 different BMSs. And if one of the batteries charges only to 55.2 and then disconnects because there's an over voltage protection, or we have reached the charge voltage, this one battery will not be charged anymore further. But the other 2 are still in the race and they keep charging. So one battery dropping out of your convoy of batteries doesn't really matter. Okay, let me change the order again. So the 100% state of charge battery is our first one again. Just give me a second here. And if we would have only this battery connected, it would set the charge current limit to 0 amps because it is full, it has even an over voltage protection, charge MOSFETs are off. But however, there's a communication between all these BMSs. It still tells the charger, hey, you can still charge with 160 amps, so 2 times 80 amps instead of 3 times 80 amps because I am full, but the other 2 are not. So keep charging, but limited to 160 amps. This is the maximum these 2 BMSs or these 2 batteries can cope with. While discharging, all 3 batteries would take part, so we have 3 times these 80 amps, 240 amps maximum discharge current for this whole tower. So there you can see the combination now of one BMS looking after one specific battery only and turning this battery off if something happens, but keeping the other ones alive and in the system available for your load and your charger. If there would be another battery now having an over temperature issue, for example, and turns off charge MOSFET, the charge current limit would be limited to 80 amps for the last remaining pack then. And this is actually a major advantage of having this communication between these 3 batteries. If you go back to my battery shelf where I have 3 different BMSs with no communication to the charger at all. And when we did the solar upgrade last November here, and we could see the next day then 240, 250, up to 270 amps coming in, it was just too much. If one of the BMSs would have shut down, the charger would have kept pushing in 270 amps, which would then have split up into 2 of the remaining batteries. And then maybe a second one tripped because of an over temperature or over current situation. The charger doesn't care. The charger keeps pushing 270 amps into this single one remaining battery. And then of course you have another overcurrent situation in this BMS, and it turns off your last remaining battery and your whole system stops working. And you wonder why. The sun is shining, you've got enough solar, the load is not connecting anymore, your inverter has shut down, everything has shut down, all the BMSs have shut down because of the missing communication. While here we can see, well, if one battery goes offline, it tells the charger already, hey, I'm not part of this game anymore, slow down. Whatever you do, slow down. If the second battery goes of your 3, it tells the charger to slow even further down. So it stays within the limits we set in these batteries and keep this all safe. So in my battery shelf, for example, I need to limit the charge current to under 200 amps in summertime, just for safety purposes. If 2 of the batteries go, the one remaining battery needs to cope with this current then, and 200 amps is pretty much the maximum I allow charging into the batteries. It has not happened yet, but it is a safety concern. While here with the communication established, there's no problem, and the whole system takes care of itself. And you probably can now understand why I'm so pushing for these BMSs to work with the communication established between the batteries and your charger, inverter, your system. It is a safety concern. It is a safety feature, a huge safety feature to have this monitoring, controlling and maintaining between your battery and your charger. Well, if you have only a single battery, it may not even matter, because if the BMS or your battery stops, the whole system will stop anyway then. But if you have already 2 batteries, and depending on your solar and system design, you could end up with these situations in summertime when you have peak solar generation. And you can have a cascading shutdown of your whole system then. Okay guys, before we conclude this video from today, I just want to show you the result of having 3 batteries in parallel with a communication setup in this bed calibration center here in the Victron VRM. You can see we've got a state of charge of 66% now, and it actually averages these 3 state of charges. We also have a system voltage of 53.5 volts. Again, it takes all these voltages of these 3 individual batteries and does an average. If the master battery takes 50 amps and the other 2 only 10 amps, it will show us 70 amps here as a current. The temperature, I'm not sure if this is an average as well? What do we have here? Could be an average as well. But more interesting is, if we go to advanced and have a look at our smart BMS here, you can see the voltage, the amps, the power, and the minimum and maximum voltage. It doesn't tell us which batteries they are in, but at least we are monitoring all 48 individual battery cells now here in the Victron system. Consumed ampere hours will not work. State of charge is the average, and I think this is an average temperature as well. And it also creates this graph here where the orange line is the maximum cell voltage and the blue line is the minimum cell voltage. And this was from our testing today, going up and down. Okay guys, as always, thank you so much for watching here. Thanks for all your great support, for all your generous donations, especially I need to mention Raphael again here. Thank you very much for this amazing hacked and pimped multimeter. Don't forget to have a look at his channel and the 2 videos he made about how to do that. I'll link this all under the video here. And I know there's a lot more to explore with parallel batteries and the communication. For example, can we connect the SEPLOS batteries to the Jackie batteries, or to the old SEPLOS batteries, or to the Tangaluma battery? Is there any communication going on then? But I'll keep this information for a later video, guys. This one is already long enough, I assume. So until the next video, guys, you stay charged, stay safe, and thanks again for watching. See you then. Bye bye. There you go. SEPLOS BMS version 3. Let me know what you think. And I guess he's a lot better in modifying these devices than in spelling. Starts.